In the previous video, we talked about differential calculus but up to quotient rule. However, in this video, we will talk about the chain rule and also we'll see how differential calculus can be used as a rate measurer. And no need to mention that we'll be covering only those areas which are going to be important and which are going to help us in understanding the fundamentals of physics. So let's get started. So we'll start with chain rule. Well, according to this chain rule, this dy by dx can be written as equal to dy by dz into dz by dx. What is this z? Z is any other function in x. Okay, and this makes perfect sense that dy by dx can be written as dy by dz into dz by dx. Well, this is the chain rule, and as far as understanding the chain rule is concerned, it's not very difficult. However, whenever we have to apply chain rule, it becomes little difficult task. We'll talk about all the different situations that you might get into, and we'll see how we are going to apply this chain rule. Anyways, let's have a look at the chain rule in some other form. For example, if we have a function y equal to f of g of x, then dy by dx is going to be equal to, basically what we need to do in this case, we have to differentiate this f with respect to g of x first, and then we will differentiate g of x with respect to x, and therefore it is going to become f prime g of x multiplied by, then we will differentiate g of x. And definitely the first differentiation is with respect to g of x and the second differentiation is with respect to x, and therefore in this situation this g of x is nothing but z in the first situation, and therefore the chain rule can be understood in these two different formats. As I said, that understanding chain rule is not difficult. However, how to apply and when to apply this chain rule is going to be a little bit difficult task. So let's now talk about the various situations that you might face, and in those situations how we will use chain rule. Well, let's have a look at this first kind of situation that we might get into, that we have a function y as equal to f of x raised to the power n. And the derivative of this f of x is known to us. For example, this f of x, let's say it is equal to x plus 1. So the derivative of x plus 1 is known to us. The derivative of x is 1 and the derivative of 1 is going to be 0. Or let's say it is x square plus 1. Or it can be x square plus x plus 2. Or it can be root x. It can be anything over here. Or let's say this f of x is a trigonometric function like sine x, or it can be cos x, cosec x, like that. So it is sine x, or let's say this is a logarithmic function ln x, or it is an exponential function e to the power x. And what is this n? This n can be any real number. It can be positive, it can be negative. For example, if n is equal to -1, basically we are talking about the case y equal to 1 upon x square plus 1. Or if n is equal to let's say 3 and it is f of x is sine of x, then in that case it is going to be sine x to the power 3, or simply it is sine cube x. So whenever we are into such a situation, then we can use the chain rule in this manner. How we are going to use the chain rule? Well, we can simply write this dy by dx as equal to n times f of x to the whole power n minus 1 multiplied by, now we will differentiate this f of x because the derivative of f of x is known to us. So in this manner we will use chain rule in this first type of situation. What is the situation again? That we are having a function raised to the whole power which is a constant. Now let's have a look at another situation. Well, we can have a situation like this, that this y is equal to t of f of x. Now what is this t? Well, this t is any trigonometric function, and this f of x is any function whose derivative is already known to us. For example, this f of x can be, it can even be a trigonometric function. That means this f of x can be a sine x, cos x, log x, any polynomial. Okay, and this t is a trigonometric function. So how we are going to do it in this manner? So let's take few examples of this function, that y is equal to sine of, let's say it is x squared plus 1, or let's say it is cos of under root of x, or let's say it is cosec of ln x, or that this f of x can be an exponential function. So if you have this type of situation, how we are going to apply chain rule, then again it is going to be the same thing, that dy by dx is going to be equal to the differentiation of this trigonometric function, where this f of x will remain as it is, and then you are going to differentiate this f of x. Basically, if you want to differentiate the sine of x square plus 1, so first of all we will differentiate sine. The differentiation of sine is going to be cos, so it is going to be cos of x square plus 1 as it is, and then you will multiply the derivative of this x square plus 1. The derivative of this x square plus 1 will be 2x. Similarly, in this case, cos of root x, the derivative of cos is minus sine. So cos root x will be minus sine root x. And then you will differentiate root x, whose derivative is 1 upon 2 root x. And then cosec of ln x. The derivative of cosec x, we will do it first, and then we will differentiate ln of x, and definitely we have to multiply the two quantities. So this is another situation that we might get into, and in fact, this, as I said, this f of x can also be a trigonometric function. So that means we can have a situation like this, sine of x, or sine of cos of x, or cos of tan of x, like that. Okay, and now let's have a look at another situations which would be identical to this situation, only because we're just going to replace this trigonometric function over here with any other function. Let's say it is an exponential function, or it is a logarithmic function. So let's have a look at those situations. Well, this is the third situation, y equal to L of f of x. What is this L? L is a logarithmic function, either to the base e or to the base 10. And this f of x is a function whose derivative is already known to us directly. Now, in this situation also we can use chain rule. For example, if you have y equal to ln of root x, we know the derivative of root x. Ln of sine x, we know the derivative of sine x. Ln of ln x, we know the derivative of ln x. In all these situations, how we are going to use a chain rule? Again, dy by dx, it will be used by differentiating this L first, and the f of x is going to remain as it is, and then we will multiply the derivative of f of x. For example, in all this situation, the dy by dx is going to be equal to 1 by root x, because derivative of ln of f of x is going to be equal to 1 upon f of x, and in fact here we can simply write it as 1 upon f of x into derivative of f of x, and therefore ln of root x is going to be 1 by root x multiplied by, now we will differentiate root x, the derivative of root x, it is x to the power 1 by 2. We will use the formula directly, and in that case it will come out to be 1 by 2 root x. Similarly, for ln of sine x, it is going to be 1 by sine x, and the derivative of sine x will be cos x. And in case of ln x, we will write first as 1 by ln x, and the derivative of ln x will be 1 by x. So in this manner, we will differentiate by using chain rule if we have this situation. Now let's talk about a situation where we have exponential function to the power, and in that power we have a function whose derivative is known to us. Basically, I'm referring to this situation where you have y equal to e to the power f of x. Well, this f of x is a function whose derivative is already known to you. Few examples are here. Y equal to e to the power root x. Well, it can be x square, it can be minus of x, it can be 1 by x, it can be anything. And in fact, it can be a polynomial, it can be binomial. That means it can be x square plus 1, x square plus 2x plus 1, like that. Okay. Another situation would be that it is e to the power cos x. The derivative of cos x is also known to us, and then we have a situation e to the power x. So basically the derivative of e to the power x is also known to us. So in all such situation, we can use chain rule in this manner, that dy by dx will be equal to e to the power f of x will remain as e to the power f of x, and then we will multiply the derivative of f of x. And therefore, in all this situation, this y is going to be equal to e to the power root x as it is, and the derivative of root x will be 1 by 2 root x, and e to the power cos x will remain as e to the power cos x, and derivative of cos x will be minus of sin x. This is going to be in multiplication, and in the third case it is going to be e to the power x as it is, and multiplied by the derivative of e to the power x, which we already know that it is e to the power x. Well, I think that these four situations are sufficient in order to understand how we are going to use chain rule. and therefore we are now directly moving on to the rate measurer. So let's now see how differential calculus can be used as a rate measurer. So let's imagine that we have two physical quantities y and x, and they are related with each other as y equal to f of x. It is similar to that area of a circle is related with the radius of the circle. So if you change the radius, area is going to change. Definitely over here also, if you change the value of x, y is also going to change. So let's imagine that we know what is the rate at which this x is changing with respect to time. Then how to find out the rate at which the y will change with respect to time? So rate measurer is basically we are measuring rate of change of the physical quantities with respect to time. So basically what we need to do, we need to differentiate this y with respect to time. So let's differentiate y with respect to time. Now remember here, if you have to differentiate y with respect to y, its differentiation will be 1. Differentiation of x with respect to x, it will be 1. However, differentiation of y with respect to time, it will be written as dy by dt. And if you want to differentiate y square with respect to time, then it is going to be 2y into dy by dt. Basically, we will differentiate y square with respect to y first, and then we will write derivative of y with respect to time. Basically, we are using chain rule only over here. Anyways, let's now write what is dy by dt. Well, this dy by dt is equal to, again, this is a function in x, and we want to differentiate it with respect to time and not with respect to x, because if we have to differentiate it with respect to x, we can directly write it as f prime x. But no, we are not differentiating it with respect to x, we are differentiating it with respect to time. So how we will do it? We can simply write it as dy by dx into dx by dt, which is nothing but the application of chain rule. And in the next step, we can write it as dy by dx is nothing but f prime x into dx by dt. So what we are supposed to do in order to find the derivative of y with respect to time, first of all, we will differentiate f of x with respect to x normally, and then we will multiply it with dx by dt. Now, what is this dx by dt? This dx by dt is the rate at which this x is changing with respect to time. So if we know this thing, we can actually find out what will be the rate at which y will change with respect to time. So in this manner, we can use the concept of differential calculus in measuring the rate of change of any physical quantity if the rate of change of the other related physical quantity is known to us. Well, since it is a quick note, so we are not going to take up any example over here. And if you wish to solve problems specifically related to this topic only, and you do not want to waste your time, of course, in finding problems in the books or elsewhere, then you can download my application whose link is provided in the description box below. Thanks for watching.